See, now we're discussing the topic determination of internal resistance. Determination of internal resistance of the cell using potentiometer. See, the before this topic, we can find the what is the comparing of EMF of two cells by using potentiometer. See, this is the two applications or two cases of a potentiometer. The using of this potentiometer, the first one we are comparing of EMF of two cells. The second one is there. What is the determination of internal resistance of the cell. Now observing, this is the circuit diagram. This is the circuit diagram of a potentiometer to find the internal resistance. To find the internal resistance. See, observing. Let a cell. Now what is the? This is the cell of EMF E. The cell of EMF E and its internal resistance. Internal resistance small r. Internal resistance is the small r and resistance box. Resistance box and it is across as we are connected by the plug key K2. Plug key K2 are connected in parallel combination. Are connected in a parallel combination. Now here, see, observing in this circuit, see what is connected by the here the battery. The battery is denoted by the B is the positive terminal and it will be the negative terminal. It is across as we are connected by a rheostat, that is the RH. R is nothing but R and it is through across is connected by the plug key K1 is connected in a series combination. This 3R is connected by a series combination. Now here the first, the plug K1 is closed. The plug is K1 is closed and K2 is open. K2 is open. Now the current draws. The current draws means the current flows from the cell of EMF E. The cell of EMF E and the galvanometer shows some deflection. Galvanometer shows some deflection. And this jockey is pressing of various point on a magnetic wire. On a magnetic wire. Certain position galvanometer shows the null deflection. Now we can stop that point and the measuring of length A to that point is the length is L1. That is the balancing point of length is L1. Balancing point of length is L1. So this is a circuit diagram. Once again we can explain. Let a cell of EMF E. Internal resistance is small r. A resistance box capital R with keys K2 is connected parallel with the cell. Now K1 is closed. K1 is closed and the current draws the wire AB. The current draws from the AB of the wire when K2 is open. When the K2 open, that means the current can be drawn when the battery of cell EMF of E. Then the balancing length L1. Then the balancing length is the L1. Then the length L1 is equal to A into N1. See the A to N1, the balancing length, how much is consumed by the L1. See, then we can write here then the E1 E cell is equal to the EMF of cell E is equal to what we can write here the balancing length, the pi into L1. Pi into L1. Pi is nothing but to resistance for length. Resistance for length. Extra day we discussing about in a. Then the extra day we discussing about the comparing EMF of two cells. That EMF E is equal to pi into L1. This is considered the equation number 1. The equation number 1. When K2 K2 is closed. See, now the first what is the K1 can be open and K2 can be closed. The current can be draws in a EMF of cell E2. Now when the K2 is closed and K2 and K1 is closed. Then the cell sends a current. Then cell send to a current. The cell send to a current through the resistance box. Through the resistance box. See now when the K2 can be closed, the current can be through the resistance box. If V is the term, if V is the potential, V is the potential difference of resistance box. If the V is the potential difference of the cell, let balancing length at L2. Balancing at length L2. Balancing length, how much is there here? The L2. Then the potential difference, what we can add here? The E replaced by the potential difference of V and the pi into L2. This is considered the equation number 2. Now the equation 1 divided by equation 2. Equation 1 divided by equation 2. Equation 1, what is there? E by and the V is equal to pi into L1 by pi into L2. Then the pi gets cancelled. The pi gets cancelled. What is the formula here? The E by V is equal to L1 by L2. But we can observe what we can find out. See, the using of this potentiometer, we can find out the internal resistance of the cell. The internal resistance of the cell is nothing but small r we can find out. See now, this is considered the equation number 3. What is considered here? The equation number 3. See here, the current. Therefore, the current is equal. What is the formula? Current I is equal to total EMF. Total EMF by total resistance. Total EMF by total resistance. Now here the total EMF. In total EMF, what is there here? The only the cell of EMF, that is constrained by the E, by total resistance, internal resistance, and here the resistance box, that is the external resistance, the small r plus capital R. Small r plus capital R. Then now can write this E is equal to, then write the E is equal to I into small r plus capital R. E is equal to how much is there? I into R, small r plus capital R. And from Ohm's law, what is there? The V is equal to I into R. Now this V value and this E value substitute in equation number 3. Now write here the E and V values substitute in equation number 3. Now E is equal to, how much is there here? The I by small r plus capital R by V is equal to how much is there? From Ohm's law, what we can write here? The I into R is equal to L1 by L2. Then here the current can be cancelled. Then the remaining term, what is there here? The small r plus capital R by the capital R is equal to L1 by L2. Now this capital R can be the dividing of the both terms. Small r by capital R plus capital R by capital R is equal to L1 by L2. Then again it's cancelled. Capital R. The remaining, what is the term is here? The small r by capital R plus 1 is equal to L1 by L2. Now then this plus 1 is taken this side. Now write here the small r by capital R is equal to L1 by L2 minus 1. L1 by L2 minus 1. Now take here the LCM, and this capital R can be taken the cross multiplication. The small r is equal to capital R into L1 minus L2 by L2. See, this is the formula of A. The formula of A to determination of internal resistance. of cell, the using of potentiometer. This is a small r is equal to internal resistance. R is equal to capital R into L1 minus L2 by L2. L1, L2 is the balancing point or balancing length, and R is the capital R is the external resistance and small r is the internal resistance.